I like to be forced to do a little bit of improv. I'm going to be mostly just showing software. So I have a handful of slides, but this is intended to be a workshop. And in some ways, this is really intended to be your dime. You all made the effort to get here. So I would like to tailor this to the room to the extent that I can. So let's begin by giving me some feedback. With a show of hands, show me how many of you have know about, have used, are deeply knowledgeable, or at least comfortable with the Signals notebook. I would hope that's most of the room. Great. How many of you have been exposed to Signals Vitro Vivo? All right, that's a smaller set. How many of you have been exposed to and used Signals Inventa? About the same subset. How many of you have heard the term and understand what the Signals Research Suite is? Okay, so I think I'm going to start with that because there's so for a subset of you, you'll have been exposed to it, you'll understand. But I think it's pretty important, maybe to level set what it is that Revvity is trying to do. So let's begin with that. So that's going to extend the slides by a little bit. But I want to level set with what the research suite is, what it's trying to do, what it's trying to accomplish. So I'm going to borrow from my friend Pierre's slides in order to do that, and talk about really what's prompted this, which is now the last bit of interactivity here. How many of you recognize what that is and have used it? Ah, I love being around people of my vintage. So this is where we were, roughly 30, 40 years ago. And so, of course, what we're trying to do is to get from this to this, make me my next drug. That's the goal. The holy grail is to be able to, from some amalgamation of data, to just have it make the next thing. Of course, that's not going to happen, but we're trying to get on that journey. And so the Signals Research Suite is really about trying to help organizations drive that journey. But of course, it has humongous activation energy. So like all good chemists, we know what we need to do at that point. We need to begin applying some heat to get over that energy barrier. And so to start driving some of that change and figure out what that journey is going to look like. And it's got lots of bumps and hurdles along the road. So the first of those began to be addressed many, many years ago by the folks who worked at CambridgeSoft, and I had the great pleasure and honor to work with for many, many years, with ChemOffice and ChemDraw that at least got rid of that manual drawing of molecules. But that put us in a place where people were still printing, signing, and binding those in paper notebooks. How many of people here have experienced the notebook signing parties where you would order pizza and everyone would sit down and they would print and sign and bind? Yeah, and that's what, of course, it looked like. The next step then, of course, was the Signals notebook, which further reduced that energy barrier and has had great market adoption. It's been very well received because now you can, instead of sitting down and manually assembling your notebook, you actually can do it digitally. You can assemble together all your Excel spreadsheets, all your PDFs, all your supporting information. But the problem at that point is, of course, you still have all your data in a place that's inaccessible, and you're processing it in some kind of manual way. And so Signals Vitro Vivo came along to try to further facilitate that process. So this is another component of the research suite. It's a component we've talked about and had delivered to the market, of course, for a while. And then Signals Inventa takes the last step of this, of course, into a perfectly smooth journey, to try to capture those data from a variety of sources in a process in a variety of ways, potentially with differing originating ontologies and descriptive languages, and put them into a common representation such that they can be easily retrieved, queried over, assembled into the appropriate analytical table, typically a SAR table, where in the past, S always meant structure, but now S sometimes means sequence. And so, but it's still a SAR table where you're trying to relate the activity to the thing you've made. So this is the journey that we have been going on ourselves. We've been trying to help our customers go through. We've been trying to learn as we go and assemble. And really, the Signals Research Suite is certainly the next step of the journey, and in some respects, the end of the beginning, if you will. So we had been building these things, and of course, it's all driven by ChemDraw. It's all driven by some of our great partnerships with tools and partners like Spotfire. And this is the foundation of the Signals Research Suite. So now I'm going to kind of step over to my original slide deck. My goal today is to really reinforce and present and drive home this concept that we have historically talked about these three components. These are the three pillars on which we've built. The Signals Notebook, which many of you already know and are using, Signals Vitro Vivo, which a subset of you are using for doing data processing and data reduction, and Signals Inventa, which is really about decision support. So make, test, decide is something you've heard from us many, many, many times. And now what has changed and what we're really pushing on now is that we have successfully combined these into a single SaaS offering, the Signals Research Suite. So that's the key piece that's new here, and that's the key piece I'm going to be showing is, this is all in SaaS. This is all delivered in one environment. It's all delivered through a web browser. But it has the same great capabilities, fantastic capabilities for data capture and collaboration, for self-service data processing, and that is one of our key guiding principles, is to try to make the data processing as self-service and easy as possible. Self-service data discovery. I hate the concept of a scientist having to go and talk to their IT people to get them to write a new query to position someplace to have access to. It needs to be driven by the scientists to the greatest extent possible. But of course, what's different now is it's delivered in SaaS. And that's true as of 2023. We've had this as an offering now for about 6 months, and we're really leaning into this because it's had great market receptivity, and it's a better experience both for the scientists, for your IT colleagues, as well as for companies of all shapes and sizes. And turning it on, and this is the key piece, turning it on is as simple as setting a checkbox. That's part of, just by that simple checkbox, Manuel at that point has access to Spotfire, has access to the data factory, has access to all the infrastructure. And that's the key differentiating piece here. Centralized user management, centralized delivery. We're responsible for all the updates. And the updates happen 10 times a year if you're on our mainstream releases, or 3 or 4 times a year if you're on the deferred releases. So that's the key piece, is to trying to make it as easy as possible for these additional capabilities, these Spotfire-based capabilities, these kind of data aggregation capabilities to be made available to you and your staff as quickly and easily as possible. So in my best case scenario here, I have you all guiding me as to which parts of the research suite you'd like to dig in on, but I'd like to, I think, particularly given the show of hands I saw, I think it's appropriate to begin with a little bit of a level set. So anyone who saw me last year, this will feel a little bit like a repeat of what I told last year, but it's now different because it's all happening in SaaS. It's all happening in a single delivered platform. But it's going to be the same cast of characters and the same company that I tend to use as my exemplar company, Hopper Pharma. So Hopper Pharma is just the example that we use, and just to be very transparent about my bias, I use Hopper Pharma because I was involved in small molecule drug discovery research for the majority of my career. So I've been on your side of the equation, working with vendors, trying to get them to do what I want them to do and using their software. So Hopper Pharma is a small molecule company. It's delivering a novel oncology platform, and it's got the first programs that are in progress and the first drug that is making its way to the market. It just closed its Series B, so it's just gotten its 50 million or 60 million raise, and so it's looking to expand. I'm just level setting kind of the context of the demo. And of course, they're going through this cycle of make, test, decide, where they're making molecules. They're running the molecules through a battery of assays to gather the data, and then they are taking the data that's accumulated together to try to decide which ones to advance. So the characters that are involved in this, in the stories that I would tell this morning, and again, I want you all, as I'm going through this, to kind of put a mark in your mind the points of curiosity, because I am at some point going to ask you to raise your hands and ask me to drill in on things. So be thinking about that. But we have Chloe, who's the medicinal chemist. She's the one who generates new molecules, and Alex, the assay scientist, who runs the regular weekly assays. And I'm going to show live this process where Chloe goes through the process of synthesizing a small molecule, registering it, putting it in a bottle, recording that bottle in inventory, and queuing up the assay submission for Alex to pick up. And then I'll show Alex picking that submission up together with all of the other submissions that have been made, putting it out on a plate, running the assay and publishing the results. then I'm going to show the team getting together and looking at those results in Signals Inventa. So the intention here is to really try to convey that message, that workflow, that experience of an end-to-end, a complete workflow that covers the full gamut of the scientific experience. Okay. So now this is the part where the rest of this is without a net. So if I am beginning as Chloe, I come into my Signals notebook, and I've a set of chemistry experiments in my notebook, and within this, then I'm going to go to the latest, where I'm not going to show you my very poor ChemDraw skills and try to draw this live, but this is the reaction that Chloe has been working up. And of course, from in here, then Chloe can go into the product and create a sample. That sample is then added here, within this first page into the samples table. And the next thing that Chloe is going to want to do, having created the sample of this, so now she has a physical material at her bench that she's going to want to use and begin doing things with. The next step in this process is to register the material. So within this, of course, it's doing the typical things where it's capturing the name. I can go in and annotate this with the additional information that is a part of the normal registration process. And directly from here, register the compound, and that registration is brought back. It's going to find a duplicate because, of course, I've given this demo before. I'm going to treat this as unique. And that sample is now decorated with the additional information of that registration. So it'll show up here in just a moment. There it goes. So here's the material. And this is the interlinking that is happening throughout the system. This is one of the key values and benefits. This will show up again at the talk I'm going to be giving at 10:30, where if you're doing antibody-drug conjugates, you have lots of things that you need to be linking together, lots of materials that you're going to be combining together. The next step that Chloe will make, having registered, so now there's a corporate identifier for this batch of this molecule, is to put this into a container. So Chloe's making one container, the barcode will be auto-generated, and initially this is going to be at her bench. So she, deposits at Chloe's bench. She's going to set that as the home location. So once the material is complete, Yep. I know, but thank you.
So you do have a net.
What's that?
You do have a net.
That's true. The net is named Jen. So put this in a vial, set its default security, record the amount that's in there. She can set herself as a responsible person. Actually, she's not a real user, so let's set it as me. And create this container. So now at this point, if I had configured this and I had a Zebra printer, the barcode could be printed out at this point, applied to the label, put into the delivery mechanism to get over to the assay scientist who's going to run the assay. I don't have a Zebra printer, at least not here. And so the next step was, of course, having created that container, having created that material, I want to queue this up for an assay. So I'm going to create a new task, and I'm going to create this task as a assay submission. I'm going to say I need to run this in HTRF against B43. There's one run. So how many of the folks who have used Notebook are actually taking advantage of some of the workflow capabilities that are already built in? So how many people here have actually used tasks? Excellent. Good. So that's going to complete the workflow for Chloe in this demo. I might come back and show a few other capabilities for Chloe in a few moments, depending on the conversation we're going to have in a little bit. But Chloe's work is now done. She's completed her work. She's synthesized that molecule. She's submitted for assay. She's put it in the inventory, and she will now go on to the next task on her to-do list. The next person who will pick this up then is Alex, the assay scientist. So, but there's one thing I forgot to do, which is I, of course, as someone submitting this, need to put in information and actually complete the task. So run this today, because of course we all know chemists are very impatient, and sets the required date by tomorrow, and then submits the task. And then the status of this will show up as submitted. All right, so then the next role that gets involved here is Alex, the assay scientist. Alex begins his day by going in and looking at the tasks and seeing all the outstanding assay submissions. So here Alex sees assay submissions that have kind of slowly accumulated, sees the urgency from Chloe to get this thing run today, and we'll begin pulling these tasks in. And from here, we'll create an experiment. So these tasks are now going to be used to initiate a new experiment. Alex tends to run the enzymology IC50 assay experiment template. And we'll define the notebook this is going to go into, the project this is on, which is B43, the technique. And I'm mostly using this as a way of illustrating, and this will come up again in a few moments, the utility or how the properties and fields associated with an experiment can be utilized for cascading assay information or contextual information downstream. And Alex is part of the enzymology department. So when Alex creates that template, a new experiment setup, of course, is brought over. But one thing that may be a novel space for some of the folks in this room is that within this template, it's got some things already built in. So this assay has got a plate map already built in with concentrations already laid out. Now, I'm going to show a couple of different variations on this because there's a different version of this that I think this group might find interesting. But this is the basic. So you have an assay template that's associated with an experiment object. When someone like Alex is completing their work, all they have to do is select that experiment object. The plate design is in there, and the thing they need to add is, of course, the actual materials that are in there. And so we're going to do that here in a moment. But you'll notice that the materials are present already because they're associated with the tasks. So to complete this plate map in this particular template, I could, as Alex, come in and say I want to add the material list from experiment. I'm just going to say, okay, here are all the tasks. I want to bring those in because it knows that there's material associated. That then provides my material list here, and then the next step is to lay this out on the plate. I'm going to zoom out a little bit to make this a little bit easier. So in this part, I will acknowledge is a bit manual. We have something that is almost there for doing an auto layout, because really what you want to be able to say is just auto lay them out into rows. So that is that auto layout piece is coming very, very, very soon. But as you can see, the operation here is all point and click to finish laying out the plate. And that's all Alex has to do to prepare the plate in terms of the informatics systems for the workup. Okay. The other piece that's been put in here is a data processing workflow. So again, what I'm trying to do is to remove from Alex's experience, A, any point of complexity to the extent possible, and B, any point of variability. So in this particular case, this is a regular production assay. Alex maybe is a lab tech, and so I want Alex's workflow to be prescribed. And so it's all part of the template, all part of the experiment object that's been instantiated when you set up a template. Now, it doesn't have to be that way. So then the next step here is, of course, to bring in the raw data. And let's go to, all right. So then I can drag and drop the raw data in. And then the next step is to launch the worksheet from here. So I've gone ahead and opened that up. So I have this here, one of these things that's open. And so the thing I want to show here is, this is coming in directly from the Signals notebook page. So that's another point of interaction here, is where when you bring data import in the context of the Signals Research Suite, that data import app knows the context it's been opened from. And so you can import the file directly from there. The other thing that's coming across that's kind of a key characteristic that I don't think everyone has been necessarily taking advantage of is that, in addition, the experiment properties that were assigned have come across as well. So when that experiment was created, so here in the properties, when that experiment was created, the user filled out these properties and the properties cascade over. Well, now those properties are also cascaded forward into the data flow. And the reason why that's important is that you want, at the end of the day, each of your data points to be annotated with the context, because you don't know exactly the way people are going to look at the data downstream. So you have to make sure those annotations are cascaded forward at a very fine-grained level. And we do that for you automatically at this point. But it is one of the, at least I would submit, one of the most important capabilities and features within the Signals platform, this concept of these properties or attributes, as they are called when they're being set up. And that gives you the metadata context, which can then be carried forward with your data flow all the way through to Inventa, and then can be used there to help guide data retrievals and data organization, as you'll see in a moment. So you have that connectivity now of the raw data being able to be pulled over, the experiment properties being able to be pulled over as part of the same experiment flow. And then the rest of this is going to look very similar to Vitro Vivo as it has always been. So within this Vitro Vivo workflow, the steps that are being assigned here is the data import to apply a grid plate design or a layout, to apply the plate-specific details, which we have under the term editable data grid, because, of course, not all experiments are done in plates. I had a wonderful conversation with a customer last night about their data is coming from Western blots, or maybe it's coming from an MST instrument or an ITC instrument. So we don't call it plate-specific details, but in this workflow, that's what it's providing. The next we'll do is normalization. And of course, we what we call there is the extensible normalization app, because we provide standard normalization techniques, but you can add whatever math that you would want. So it's extensible by you. And then curve fitting, and then publication. So because not everyone here has seen Vitro Vivo, let's go through it all. I'm going to close this, but realize this is another piece of the platform that isn't necessarily fully utilized by everyone, which is you have here instructions. And those instructions are created by you or the author of the workflow at the time you're creating the workflow. So this is not fixed. This is set up by you at the time you're configuring a Vitro Vivo workflow. The raw data file, which is a plate block file, was imported, parsed, and interpreted into a columnar listing. A preview of that was shown here. Excuse me. The next step here was to bring in the plate map. So this plate map is coming in from the notebook page. So if I go and look at the materials here, and apparently, that's right, because I opened this earlier. But this plate map's being brought in dynamically from the notebook page. Okay. When I say next, it's going to bring in the plate-specific details. So the point of this being, where before the relationship between, that's why I'm getting ahead of myself here. The relationship between the Signals notebook and Spotfire was, was a little bit fragmented. Now it's very, very tightly integrated. So it's pulling in that information, and you'll see the publication at the end of this is publishing to Inventa. And so there's a lot of work that's been done to progressively tighten up those points of integration. And that culminates with us with something that I'm going to show at the very, very end. But this plate-specific information is now coming in from that notebook page as well. And sorry, I've kind of jumped the shark here a little bit in that I got myself confused about which Vitro Vivo demo I was giving. So let me pause and take a step back. I apologize for this. There's a second way to set up experiments that I think folks will find fairly interesting. So, and that is actually the Vitro Vivo file that I'd opened when I was preparing earlier. So if you go back and look at a different notebook page here. This one here. So this is also, very much the same concept where I have, I've set up some tasks, I've set up a template, but here instead of bringing in those materials from the tasks, I've brought them into this admin defined table. So this is a notebook table, but with some additional columns in here. So what this is really intended for is one of the weaknesses in that first example that I'm showing you is that the concentrations are fixed. But that's often not the way you tend to run them. Often organizations will run where you have an assay plate which begins with the top concentration and a dilution series. And so we fully support that as well. And in fact, that has become one of the primary ways that I encourage people to set up their assays, because it provides a lot more flexibility. So here you have a setup where the materials are being, you have different dilution series for different molecules all in the same plate. And so the rest of this plate map is very similar, where you're bringing in your compounds, but the materials are being brought in from that listing there. So I apologize if that's a little bit confusing. But at the end, what VitroReview is doing is it's taking that raw data file, it's taking the plate information, it's taking this material information and merging it all together. Oh, yes. The plate table, so if you go back and look at this, the plate table here has the dilution step. And so it's showing, it's actually calculating the concentration on the fly. Yeah. Yeah, so I brought the raw data here. And then in the data import, basically, if I were to go back a step here, I can bring it in. So there's this dialog box which allows me to select which files to bring in. Yep. Yeah. So in a piece which I haven't gotten to yet, which is in Inventa, there is a capability in Inventa for doing what's called pipelining. And pipelining is where you can have essentially the Inventa backend be monitoring a folder location, on a scheduled task. So once an hour, I'll go look for new files and do the data processing. Transparently configuring that's more complicated, and that probably is a little bit beyond what I was going to try to cover today. But there is a mechanism, a capability by which that can be done. I just noticed the time, and I do want to make sure that I give time and attention to the Inventa piece of this. So I'm going to press on just a little bit. So in the next step of this, I've brought together my raw data with my plate map, with my plate-specific information, and I'm going to begin applying math. So this is the normalization app. It comes with a set of visualizations that I can, I typically turn off those two if I want to focus in on the plate map before and after. From here, this is the set of just out-of-the-box normalization techniques that we have. But if you have additional techniques, you can look for shared methods. So you can basically turn this on, and any customized normalization method you might want to use is applicable or accessible from there. Once the data has been normalized, the next step is to do curve fitting on it. And so one of the things that I'm quite pleased with is that we now, as of, for anyone who had used VitroVivo before, we've now made several updates where the whatever layout you create is the layout that will be preserved, which means that when I clicked to this page, several things happened simultaneously. So let's just briefly talk about the things that happened here. So that tabulation of data on the plate was brought in. It was put into a curve fitting. So this is, a 4-parameter curve fitting, defined by kind of specific constraints. So this is not the simplest version of the curve fitting. This is the kind of fitting you would expect, where you can fix or let float the upper and lower asymptote. You can set constrained ranges on any of the parameters, et cetera, et cetera. So in addition, you can see a view here where you're getting the individual well values that went into that curve fit, as well as calculations of the final QA/QC. Things like a final reported IC50 that's being respectful of the limits of the assay, a calculation of a greater than or less than sign. So all of the business rules have been applied, as well as the pure math of the curve fitting. And then the next step of this, and of course from here you can do things where you can, lasso points and knock out points, providing particular reasons and so forth, as you would go through that process. But the final step here then is publication. So having assembled a set of data with all the metadata, with all the information, I now want to be able to publish these results. And so to do this, this is now going into Inventa. So as part of the Vitro Vivo workflow, the final step of that workflow is to go and deliver the data into your database, into the back end. And hopefully I'm still online with the session. We'll see. There it goes. So here I'm publishing. And so because this is part of a workflow, everything about how this publication should happen is known, though we still require a scientist to do review. That's something I feel very strongly about, is that scientists have to be engaged with that final provenance of the data. And so this is a map. So within here you have the term we use for this is a measurement type. So in this case, it's an assay result, but maybe it's not an assay, maybe it's a calculated property. For us, they're all measurements of things you have made. So, and then there's a map that says, okay, for the column that's assay date, we're going to use assay date. For assay name, it's going to be assay technique, which is a field that came originally from the notebook page, if you recall. And so here is how you take that final assembled information and deliver it with contextual information to the database, the back end. Very importantly, though, you're also delivering what we call the details measurements. So we talk about a parent measurement type, which is maybe your IC50, and then it's supported by the details measurement types, which are the individual well level details. And the importance of that I'll show you in a moment, but we are very thorough about tracking all the layers of information that are what makes scientific data so interesting and complex, because scientific data is not flat, it is layered. Okay, so within our infrastructure within Inventa, you're able to fully model that rich complexity of the data. When the scientist is happy with the results and happy with the mapping, they will then be prompted to publish this. The publication, they give it a name. And I always call it demo delete me so I don't forget. And then these data will go in to the back end, to Signals Inventa. If something changes, then the scientist can come in, make the modifications to the results, and republish them. Okay, so let's talk about what's next. So, of course, Alex, having completed Alex's work, would notify through Signals to Chloe, hey, your new data is available, go look at it. And then Chloe and Alex and maybe the rest of the team would get together, and they would go into the Signals Inventa dashboard. So this is a new capability that is very specific to the Signals Research Suite. It is another place where we are more tightly tying our foundational capabilities together. So these dashboards are, for example, team dashboards that have been put together that represent, whatever the team is trying to accomplish, whatever view of the data the team's trying to accomplish. And a very typical one might be this example Inventa analysis object. So this is the one that we often use for demos. And so from here, the scientists can directly launch this in Spotfire. What that looks like then is shown here. So this is using the key Signals Inventa capabilities for doing data querying and data retrieval directly into Spotfire. So effectively, and this will take a second to come back up, but this is a graphic interface for a scientist to go shopping for the data that's of interest to them. The concept of the global search interface is that you have this hierarchy of data. So in the process of the publication, the data was automatically organized by virtue of some rules were set up by the administrator. Those rules are very flexible, they're very modifiable. If you make a change to them, you can essentially trigger what we call a load all, which will reindex everything and reorganize your data. Please take it from me, having worked in this space for a very long time. In my past, when I had to do that kind of reorganization, that meant rewriting database views, republishing things, going through lots and lots of steps that would often take weeks. Literally, within this, there is the capability of doing a data reorganization that I had to personally do in my past. In the past, it took me 6 months. In this, it took me about 2 minutes. Now, that's a very, very specific and idiosyncratic aspect of it that only people who have dealt with the idiosyncrasies of scientific data management will be important to you. To the scientist, all that matters is they can come in and they can say, I want to find the results for B43. And the hierarchy will immediately trim itself to those results that are useful. As a scientist, then I can begin checking or unchecking things. So let's say I get rid of this one. And in real time, the system's going to give me feedback about how many compounds and how many results have been found. It is this interactivity that is kind of the key user experience we're trying to go for here, where oftentimes legacy systems require that a user go and spend time assembling a query, running the query, only to discover that the results were not quite what they were expecting, and then they have to go and build a new query. Here, the intention is that it would be more interactive. And I definitely am having some limitations on my bandwidth here. But having found the results of interest, and having applied whatever criteria might be of interest, for example, criteria related to structure, or related to any of the assay results. Yeah, I'm definitely being limited in some way. I pull those data down, and it will automatically build a SAR table. So this SAR table, I as a user didn't have to do anything to build. It's being driven by the metadata that was part of that entire data management and publication process. And this SAR table, I'm going to be talking about it more in the next talk I'm giving as well, is incredibly capable for both handling small molecule as well as large molecule data. So this has been designed and is a variation of a table that has some really scientifically rich features, things like being able to do a one-click transpose. So oftentimes people like to look at things in an Excel-like format until they're getting to the candidate nominations phase, in which case they want to see it in the other format. Well, for us, going back and forth between those is a trivial click. But more importantly, as in this particular case, I pulled down information that includes that data that I just published. So here I can see the IC50 measurement type, and I can see all the supporting data. And this provides me then an easy ability to be able to easily superimpose and compare multiple compounds across different stages of the project. Now you're in the full richness, the full capability of Spotfire for doing visual analytics, augmented by the scientifically relevant tools that Revvity has added into it. Included within that are things like assay correlation, things you would expect where you can come in and be able to see the way two assays are working with each other, but also things like being able to add a rich set of chemistry calculations, as well as some updates to the lead discovery chemistry features that many folks here probably have used in your past. Things that will allow for a more visual representation of the substructure searches, being able to see directly from here, include and exclude in a dynamic fashion, which substructures you might have interest in, doing things like scaffold extraction, as well as depositing the results into a SAR map. Right. So the intention of this is looking at R group analysis. Right. Within the capabilities that are now in Inventa are some incredibly rich, incredibly advanced chemistry capabilities that I suspect even the people who have used Inventa have not begun taking advantage of. So I'm reaching the end of the time, but I do want to show a couple of other things here. So within this are things like matched molecular pair analysis. So here I've done an MMP analysis over the data that's within the project, such that directly from here I can lasso a set of the molecule that I want to change and filter down and see any changes that are relevant for that piece. So, but here you're able to see the before and the after and see for that the effect that it's predicted to have, or observed to have rather, on your assay results. And this is intended to help look for the parts of the molecule that you can make changes on. You also have this concept of a reaction pair finder. So here is a left-hand side to right-hand side comparison. And here you're seeing molecules where exactly one thing has changed between the molecules, and the fact, in this case, of a chloride to bromine change, and the effect that it has on your different assay results. And these are all just capabilities that are built in. There is an incredibly rich set of data functions that are now part of the product and just come for free within this for both small molecule and large molecule analytics. So I would strongly encourage folks that have access to this to go dumpster diving in terms of all the data functions and capabilities, because most organizations at this point are still just scratching the surface of the rich scientific capabilities that have been added into the platform. So we have 3 minutes left, and I do want to keep us on track. So I'm going to ask for a few more questions. I'm going to kind of quickly wrap up. There's so much more that I could cover. In the last year, we have built out a tremendous amount of capabilities in terms of the inventory system. And we've built out so much more in terms of the tasks and request workflows than the little bit I've touched on here. We've built up so much more in terms of the experimental properties, the templates, and the way those things can be managed to help drive your science. Vitro Vivo, I don't know if everyone knows this, but Vitro Vivo covers all of the same math that you might find out of a tool like Prism. Literally all of them, because we've gone through and built them. Plus, it's open-ended, so you can put in any other equation that you want. So I've shown probably the simplest example here of a 4-parameter fit, but it's been used for every possible fit that that we've been exposed to as being a need and as a requirement. And then I've touched a little bit on Signals Inventa and the rich scientific capabilities there for doing decision support. And I will be giving another talk on the Signals Research Suite at 10:30, focusing on the biologics domain. I'll be going deeper about what Inventa can do to help drive your science there. So I'm happy to take more questions until I get kicked off the stage. I'll leave you with just one last thought here. So we've produced a lot in the last year. It's hard even for our internal staff to keep up with everything that we're producing. You know, we have an R&D organization that's really cranking at a wild velocity, and I'm incredibly proud of the amount of stuff they've been producing. So I've been talking a lot about the Signals Research Suite. I mentioned the analysis object. The notebook, the Inventa Material Sync, is part of just the delivery of a research suite such that things are working tightly together. I've mentioned and showed very briefly the matched molecular pair, reaction pair, blast searching, and the dozens of other data functions that are built in and delivered as part of the product. We have an inventory. Decrements from containers was a big deal for a lot of our customers. In the next talk, I'll be showing related entities and how that can be used for things like antibody-drug conjugates. There have been an almost incalculable number of improvements being made to Calculations Explorer, including something I was very excited about, having the layout preserved, because that turned out to be a bigger deal to get working than we thought. We've also done a huge amount of progress and effort in the in vivo space. I didn't have a time to touch on this now, but we have things where we're able to go through a PK workflow, including generating the mass spec sequence file, reading in the mass spec results, and doing the rack layout. And then, of course, worksheets was talked about at length yesterday, and will be talked about again in my next talk. And this is just a fraction of what's been delivered in the last year. It's really fun right now being part of the team getting to deliver this stuff, because things come out every month.